So two vectors u and v are orthogonal or perpendicular to each other if the angle between them is pi by 2, right? Pi by 2 or 90 degree. And we know that cos of pi by 2 is equal to 0, which means that the dot product of u and v, which is u dot v, will be equal to length of u multiplied by length of v multiplied by the cosine of the angle between them, which is pi by 2, will be equal to 0. So basically, which it means that the dot product of two perpendicular vectors will be 0. You might remember that we learned that the standard basis vectors are orthogonal, and we can prove it now. So for I not equal to j, we have the standard basis vector ei as 0 0 1 0 0. So ei has got n elements, all of them are 0 except at the ith location the element is 1, and ej is again has got n elements, all of them are 0 except the one at the jth location, right, which is again 1. And if I were to find out the dot product of ei and ej, I'll get 0 into 0 plus 0 into 0 plus the ith term will be 1 into 0 and the jth term will be 0 into 1 and everything else will be 0 into 0, and this will be 0, right? So the dot product of ei and ej is 0, and hence we can say that ei and ej, these two standard basis vectors, are orthogonal to each other. So I want to quickly go over some of these theorems for dot products, and I'll not be proving them here, but I urge you to take examples and convince yourself that these theorems are indeed true. So let u, v and w be vectors. Okay, let's say u, v and w are vectors, and let's say c be a scalar. Then the theorem 1 is that dot product is commutative, which basically means that u dot v is equal to v dot u. The second theorem is distributivity. So dot product is distributive. So u dot v plus w is equal to u dot v plus u dot w. The third theorem is scalar associativity. Which basically means that a vector u scaled by the scalar c and dot of this with vector v is equal to u dot v times c and is also equal to u dot cv. And the last theorem is that u dot u is equal to the square of the length of the vector u.